will start now with the second paper. Then after we finish, we will go to the Tunisian paper. The title of our paper is a proposed emergent scale extraction methodology by Mr. Eid Emary from Faculty of Computers and Artificial Intelligence in Cairo University. Mr. Eid, you have in total 22 minutes. So let's have 15 minutes for the paper itself and 7 minutes for questions. Go on, please. Thank you.
Okay. Good afternoon, everybody. I would like to check first if you can see my screen. Can you see it clearly?
Yes, we can see your screen. Yes.
Oh, okay. I will talk about a proposed system for emergent scale extraction from unstructured text. At first, let's define what is a scale. A scale is defined by, it is defined as any expertise or talent that is useful for a given job, okay? Performing any job requires the use of multiple skills or skill set. So there is a skill set defined per job or per career. Many jobs require skills related to physical or digital tools, which is called technical skills, and this is our goal. Actually, here is an example of a job post. As you can see, there is a DOM of text, which is full of skills that is requested by the offering company, as you can see. So we are targeting to capture these skills. Okay. Now let's go to what is the word emergent skill. An emergent skill is defined as a skill that is increasingly demanded from the job market and not yet recorded as a glancing skill. So we are targeting these emergent skills so that we can enhance our planning for the future, especially for universities, training mediums, and so on, so that they prepare their courses and their programs so that to reflect the market needs. Okay. How to detect emergent skills? Let's go now to the how. In here, the process of detecting emergent skills and the market trends totally relies on posts from the different hiring platforms. So we have some sort of collaborators and scrubbers, so that we capture from the posting mediums such as Indeed and WhatsApp. We capture the job posts from these websites, and hence based on it, we can check we can make some sort of market analysis and so on. Okay, so we capture these job posts along with its posting date, so that we can catch or define the emergent skills. So what is the challenge in here? The challenge is that all those job posts are full, is a huge text that is filled with unstructured text. So it is very difficult to capture the skills from this type of text. Secondly, we have skills defined by different ways depending on the posting company. So you may find a word C, and in another post you may find it as defined as C++, Java, and J++, and so many different skills are defined with different terms, but they mean the same thing. Okay. Also, there is some sort of context dependency of detecting these skills. In here, we are talking about the generic framework for our proposed system, which is composed of job posts, skill extraction, skill representation, then skill standardization, and after that, we reach the emergence detector system. Okay, at first, let's talk quickly about the job the post collection phase. In here, we rely on a data that is posted by Kallel, which is from the WhatsApp website, which is a famous one. As you can see, each job post is composed of title, company, location, type, level, and years of experience, and a list of skills. So this is mainly our data set. Here is an example as we already showed. In here, the main end of skill extraction module is to detect a list of skills from this dump text. Mainly, we relied on some sort of lookup table to find skills in this dump text by after applying some sort of natural language processing primitives. In here, we highlighting how to increase our dictionary, which is to make it more dynamic and more reflective. So we have an initial dictionary of skills. After that, we somehow guess skills and add it to this dictionary. As you can see, we relied on simple fact that is skills are commonly appearing in nearby locations in the job post and commonly separated by the same delimiter as I am highlighting in this slide. So you can see Data Factory Azure, for example, and SQL are in the dictionary, the base dictionary. But the Databricks is not there, so in here we can guess that Databricks is a skill, but it is not in the dictionary, so we add it to enhance our dictionary. Okay. After that, we are going to the skill representation module, which targets to create a representation for the given skills rather than being words or so. We convert it into a k-dimensional space, which is a semantic one, so we can find nearby skills coexist in nearby locations. Okay, this is very common actually in natural language processing, and we hired the same technique for capturing and representing skills. As you can see, it is a simple neural network with one skill used to predict other skills from the same job post. After that, we reached, as you can see, a simple graph representing the different skills, and we can guess or we can see that nearby skills in this special representation are also related semantically. Okay, after that, we are going to highlight our skill standardizer, which quantize this space simply so that the same skills are exist in the same bin and hence have the same skill code. After that, to detect the emergency, we monitor the frequency of existence of skills over the time by suitably quantizing the time, and then if we have a skill that is increasingly demanded, as you can see in this slide, we define it or we catch the skill as an increasingly demanded skill, and hence we highlighted it as an emergent tool. Okay. Here is I would like to share with you some of the results. As I highlighted, we totally depend on WASF data set, and also we hired some data from Indeed website, which is very famous one. Also, we have more than around 4,000 tuples or job posts plus 6,000 from WASF. And we use Python, for example, Spacey and LTKA for the processing of NLP. Here are some of the skills that are existing in the same bin as I highlighted. So human resource HR is based on our model are the same as human resource, is the same as HR, is the same as recruitment employee, and so on. The same for marketing and e-marketing. Some companies mention it as marketing or e-marketing and so on. The same for Adobe Photoshop and Adobe Illustrator are very close in the semantic space. The second table highlights the number of detections based on increasing the size of our lookup dictionary. Here is the final result, which is related to detection and undetection of skill. We tagged around 73,000 skills, and based on our proposed model, we can catch around 73,000 ones, and we only missed around 24 false detections, while we have around 1,045 undetections in the system. The number of detected emergent skills are around true detections with around 28 ones, while we highlighted some of the false or non-emergent skills, around 40, and all of them are almost accurately detected. Here are we going to the conclusion. Our proposed system is to some extent very accurate and efficient, while it is robust against noisy postings and so on. Also, we can see that it is adaptive, where we are relying on adaptive dictionary, as I highlighted. In the future, and we're currently working on this phase, we are to enhance our data detection module, and we scrap more and more data so that we improve the efficiency of our system. And thank you very much. That's all from my side.
Finished before time, actually. So we have enough time for questions. If anyone has a question here or anyone online has a question, please go on. Okay, it seems we have no questions. Thank you, very much, Dr. Eid. And now we will start our second presentation with our second paper, which was actually the first, but due to some technical problems, we have changed the order. Sorry again for this, Mr. Abdelaziz. And now it's time for the paper entitled Olive Tree Health Monitoring Approach Using Satellite Images and Based on Artificial Intelligence by Mr. Abdelaziz and Mr. Achraf and Mr. Ahmed from Tunisia. Please go on, you have the mic.
Hello?
We hear you. Go on.
Thank you. Very good. Thank you, Mr. Walid, for allowing me this occasion to present our work. My name is Abdelaziz Kallel, and the presentation is entitled Olive Tree Health Monitoring Approach using Actually, this work is within the project 3E, Artificial Intelligence for Agriculture in Africa, and it is a joint project between Orange company and the Digital Research Center of FAMECSE. So why we are studying
Mr. Abdelaziz,
Olive
we don't see your screen. Are you sharing something?
We have to know that 30% of the cultivated land is olive tree growing in Tunisia, and also 50% of our total agriculture export is related to olive tree, for instance, olive oil. Also, I can point out that this is also the case for different countries in the Mediterranean area. And remember that the relationship between this civilization and the olive tree started 600 years, 1,000 years ago. So now what kind of challenges we have? For instance, hot temperature, or also water stress, and pest and disease early stage anomaly detection. For that, we proposed a platform to do that. So I explained the solution. Actually, we have a satellite sensor. This satellite produces image series, and this image we try to detect change. The change can be in time or in space. For instance, if with satellite we detect suspect change, so the farmer and also the agronomic expert are informed, and they are asked to check in the field if there is suspicious problem. It is possible to have and to do analysis in laboratory. And if the disease is confirmed, it is possible then and to propose a solution to fight against. And along all this time, the farmer is informed. So in this project, we are dealing with the verticillium fungus, which is now in Tunisia and also in different countries. So this fungus we can see in this figure. For instance, on the left side, it is a normal healthy tree, and on the right side, it is a tree with verticillium fungus. We see that in this second case that the leaf number decrease due to the loss of leaf, and also the leaves becomes yellow and rolled up. So we can see that more clearly on the right side with this twig example. So on the top, it is a normal twig, and on the bottom, yellow and rolled up leaves, which is due to verticillium. So in our case,
Mr. Abdelaziz, can you hear me?
have different study areas around the monastery and the city in Tunisia. Yeah.
Mr. Abdelaziz, you are not sharing your screen. We don't see your presentation. Can you please share your screen?
Sorry. Why?
Okay, thank you.
Okay.
Go on, please.
Yes. Good. So this is the verticillium fungus that we are dealing with in this project. So we see the olive tree normal and the olive tree with the problem, and it corresponds to loss of leaves and also yellow and rolled up leaves. The study area in Tunisia or in Monastir and FAMECSE nearby the city. There are 6 study areas. So how to solve our problem? Our approach is based on physics and artificial intelligence. So if we have a scene composed by trees, grass, and the soil, bare soil, the atmosphere, it is sunlit by the sun and observed by the sensor. So the radiation is actually propagated from the sun and reach the different element. It will be scattered one or many times, and a part of the radiation will be recorded by the sensor. The sensor will produce the satellite image. So in our model, we propose to simulate such image. We simulate image close actually to real image. Moreover, if it is possible to change, for instance, the tree size, the leaf number, the leaf color, the leaf density, the soil color, etc., it is possible to construct a huge database of images with this huge database, it is possible to use after that artificial intelligence to link the image to the properties of the vegetation. And then if we have actual image, it is possible to use it as input, and the output of the artificial intelligence will be the properties of the vegetation. So, but the question is, what is the relationship between the color of the leaf and the biophysical property? As the fungi, for instance, decrease the chlorophyll, but how we can detect the chlorophyll? To understand, let us see this image of some leaves in different bands. Actually, here we have many bands in the visible and near infrared. And on the right side, I plot the x-axis is the wavelength and the y-axis is the reflectance. It means the brightness actually of the leaf. So the wavelength means the color. For instance, the first wavelength, or here the visible, then near infrared, and then shortwave infrared. We see that in the visible domain, the brightness of the leaf is not too high. Why? It actually due to the absorption of the pigment, in particular the chlorophyll. In the shortwave infrared, the same thing, we see that there is a decrease of the brightness, which is due to the water absorption. So this means that if we decrease or increase the water content or the chlorophyll content, shortwave infrared. So if we have information like that, like this spectrum, it is possible to estimate the biophysical property of the leaf. So in our case, we use Sentinel-2. It is composed by 10 bands, and we can the visible, near infrared, and shortwave. So all these bands are linked to the chlorophyll absorption and so content, and the band here are linked to the water absorption. So given this band, it is possible to think that it is possible to link the signal or the image to the properties of the leaf. Then as physical model, as I already said, we need a physical model to simulate image like the actual one. So this model consider a realistic mock-up and then simulate the propagation of the light and produce at the end an image. For instance, in our case, if we have one olive tree, it is possible to consider it, then consider the soil background, and it is possible to add another layer of grass and so on. So for inverse modeling, it means the estimation of the properties given the reflectance. The input or the Sentinel-2, in addition to the observation angle, of course, because the color of the image depends on the observation angle. So we consider the 10 bands as input, and the output we find the LI. LI actually is the leaf density, CEB is the chlorophyll content, CW is the water content, and also the soil brightness. Soil brightness is also estimated in our case because the estimation is highly dependent on this factor. So if the soil is not well estimated, will not be very well estimated. So this network is trained using the simulated data. As I already explained, we create a database of simulation. We learn this network, and then it will be used to estimate the property given actual images. So let us here see some result. Here I will show only two fields, healthy field and infected field. in the area nearby Monastir. So then we estimate the biophysical properties. So the first row are the chlorophyll content. It is from 0 to 100. We can see at the beginning. Sorry. So the chlorophyll content is maximum for healthy field, which is good. And it is not the case for the infected field. We see that the decrease of the chlorophyll content. Then we have the leaf density. The same, we see that the leaf density is the highest for the healthy field. This is not the case for original image. We can see that the trees in the infected field are smaller than the trees in the healthy field, even though these two fields are twins because they belong to the same family. So as a result, we have a threshold linking chlorophyll and leaf density. And if we are less than the threshold, the pixel is considered as infected, and higher than this threshold, the pixel is considered as healthy. And we can see that for the healthy field, we have just a few isolated pixels assumed infected. Sensor noise or something like that. And for the infected field, we see that many pixels are assumed infected. So we can confirm that our model out that through our developed application. Finally, the conclusion, we developed a model for olive tree anomaly detection using satellite image based on physical and artificial intelligence model. Result proved the performances. In our perspective, we would like to extend the model to other anomalies such as other fungi or other virus such as Xenella, which start to be existing in Europe. Also, we would like to detect water stress, nutrition stress, such as, for instance, all kind of nutrition that needed, like phosphor, it is really needed by the tree, and nitrogen. Also, we'd like to use different kind of sensor in addition to the remote sensing sensor, the sensor in the field. For instance, if we have a climatic station in the field, it is possible to detect water stress or hot temperature and so on. So, thank you for your attention.
Thank you, Mr. Abdelaziz. Now it is time for questions. Any questions? Now we have, I think, a short break. Then in a few minutes we will start the tutorial sessions. Thank you very much.